All right, I'm getting into momentum, potential. I don't know, momentum just being kind of like forced. I don't want to say conventional physics as much as well. Yeah, I guess I do want to say conventional physics. I do. I don't. I really want to keep it simple. So momentum's more of like the what they have now going on with Einstein, just kind of like these whatever the conventional theory of czar bombs, where you just have like a ever expanding amount of gunpowder. You put that into one. You put that on top of an atom bomb. You put that on top of a nuke. You put that on top of a you put an infinite amount of infinite. You put more gunpowder, in each one and all that, and then it turns into a czar bomb. The czar bomb's like 50 times bigger than a nuke, and that's when like you deal with like the assumption that there's like a infinite potential in actual energy. I mean, is there a way to actually prove conservation of energy? I mean, as cause and effect, or as I should say, as a Newtonian metaphysical. Let me stop saying that. As a Newtonian, like more Platonic particle theory, like infinite, I guess, energy or mass into a different source of energy is not going to be possible, because there's never going to be a breakage. There's never going to be a lapse in time necessarily. That's how they do this kinetic energy thing, and that came in around. Well, that did come in 100 years after Newton, which was like the 1700s, on like experimenting with pounds of different pounds of balls. So a bigger ball would drop, and then a smaller ball would drop. So the bigger ball would drop, and I don't quite get the parabola yet on how. Well, yeah, and how they do momentum now. So I mean, kinetic energy is dealing with momentum, because there is supposed to be this free energy, which would be the kinetic energy. Like they also have electromagnetism, but electromagnetism I haven't gotten into yet. I haven't gotten into uh, Feynman yet. So Feynman is the guy for electromagnetism, and Leibniz is the guy for kinetic energy. Einstein is, I guess, just the energy guy, and so that's how they did it. That's how they kind of forced this theory. I'm kind of saying that it is on gold, in that like they needed to meet, like they started mining gold after. Well, I guess they did. Well, they could have started mining gold then, like when they actually came out with kinetic energy. Sorry, kinetic energy. Like they could have started mining gold, because it said that the California Gold Rush. Okay, so California Gold Rush happened like in the 1830s, like around ontology or philosophy, and then that's when California Gold Rush started. And like all the other, she was from Russia, Blavatsky, and all the other kinetic energy like that. I mean, so gold could have been mined, and I'm just saying, like you need like a sort of like a mass media, like a mainstream media sort of thing, to understand, like sort of like a word, like kinetic energy equals mass times velocity squared. It is a like, all right, so I do really see how it is a broken concept, because they have this. They instead of using a 16-pound ball and a 8-pound ball, they use these like drivers. I guess they call them carts, and the carts deflect, and so like they do the small cart first instead of the small ball, and the small cart goes, and when the small cart goes by itself, it's the same average speed as when it hits the big one, but it doesn't hit the big one for the big card. It doesn't hit the big one first. It hits the big one second. So at the same speed or the same potential. I'll just say same energy. And then when it hits the big card on the Lewin video, it bounces. So like that would be like could be like a atom with it could be like a nuclei hits an atom. So a nuclei is smaller than an atom. So just for review's sake, to my knowledge, an atom would have electrons and protons. Positive and negative. Magnetism revolving around the nuclei, and the nuclei would be inside of the actual atom, so you could say something like that. And then so the smaller one would hit the big one, and then when the big one gets hit off, it doesn't really matter what the momentum of the big one is. I guess mathematically it does, but there is a potential energy that is inside the source of like that reflection, and so they're not counting that reflection, but that reflection has they're calling free energy, and yeah. So and then that free energy is, when you're considering CERN, well, I call it like the atom splitter for some reason, but I guess it's the Hadron Collider. And the Hadron Collider, alright, so you could say they're splitting atoms, so they're just sending atoms at a super high speed, and I guess to break that source of like if you have an atom, and it's moving like next to another one, they're saying, I suppose that they're saying that the potential energy is hidden inside the sort of like a reflection. So it's going like light speed. So the atoms are going light speed. Somehow they're going in a circle. I haven't gotten into it, but I would say potentially, no pun intended, that the atoms going at light speed would be, they would just have to, like, somehow the speed would change and they would reflect. So I'm considering that, like, in terms of like nuclear physics, there's no way that, nuclear, I guess the only way that the atoms would be able to split would be like in a nuclear theory, but I don't really know how to describe like nuclear energy, like probably kinetic energy or something like that they would use. But you could also, like, I don't know, in terms of the law of conservation, if they're all moving at the speed of light, there's gonna have to be, like, if you use the inverse square law, whatever that is, or if you use like mc squared, for example, then you could just say in an anatomical particle sense, then the at light speed, then light could actually like kind of like source into each other, like it could like actually like grab each other. So not grab each other, that's definitely the wrong word, but yeah, it could, because it's going to be, it's going to end up being, it's always going to be like deflection and stuff like that. But when particles, I suppose in a conventional sense, if they're not using the polarity, and then they have to use magnetism, the plus minus, and the like kind of like revolving those like revolving reflections of the electrons and protons, and they have to somehow source in and out of each other. In terms of there's the speed the light is going and stuff like that. So they would the atoms would be moving that quickly. Well, they wouldn't be moving that quickly, but I guess they're attempting to move them that quickly. Is that what's done? So I don't know. I'll just leave it there in case anybody watches this.